Welcome to the C Makefile Tutorial 101. What we're going to cover here is what the basic syntax of a makefile is, how to use it to build two separate programs that share a common library, and we're going to review some of the one of the implicit rules and just see the functionality and how it works. So let's get started. First of all, you're going to need a C compiler. I'm using Ubuntu, as you can see here. You can check your version and release version. This is Ubuntu 20.04 and codename Focal. So I have a GCC compiler version of 9.3.0. If you do not have a GCC compiler installed, you can run this command and get access to the GCC compiler. All right, so next up, we'll be creating the directory that we're going to place all of our project files in. So make directory, and that is going to be makefile tutorial 101. And if you want to change into there, now we can create all the files that we're going to be using. So first is you can type touch, and that'll create a file, and then print greeting 1.c, and then you want to print greeting 2.c. And for the third, we're going to use shared lib greetings. So this is going to be our shared library. And then lastly, it is the makefile. So you should have a total of 4 files. So 2 of them are going to be programs. The shared library is the common library that both of those reference. And then the makefile is going to build everything, 2 executables. All right, I use VS Code for my code editor. If you're interested in how to get that installed, uh, you can navigate to YouTube, search for Programmer 3591, and look for the video install VS Code via Linux Ubuntu. Now, these instructions are very specific to this version of Ubuntu. So there is also a URL within the video that'll show you exactly where to go. It's a Microsoft site, and they tell you the exact instructions per release of your Linux distribution. So go there, and they've got everything you need. Or you can follow along if you just so happen to be on the same setting. All right, moving on. So to open that, I would type in code and then target the directory. What that's going to do, that is going to drop me in here. So as we can see, the target directory we've just made is containing all of the 4 files we just made. So let's start with print greeting 1.c. Now that's going to be an actual program. So we're going to include the main function, the entry point for the main program. Extern means this function is not defined within this file, and you're going to have to go somewhere else and find it. So that is going to be used by the linker during compile time to locate when we call print greeting 1 to find where it's located at within the source code. All right, so pause it here, make sure you get everything typed the same, and we'll move on to print greeting 2. All right, so print greeting 2 is similar to print greeting 1. We're just calling the print greeting 2 function. It's an external function, and then we call it from within the code, then we return 0 and close the program. Pause it here, get all your code written, and then we'll move on to shared library greeting. So the shared libs greeting is here. So this is the shared library. You're going to have to include the standard input out header because we're using fprintf. So this is our first function declaration, which is the print greeting 1, and that is fprintf stdout. So that is going to target our console output of the current process. And then greetings Earthling, your culture is flawed is the greeting I have for greeting 1, and then greeting 2 is just the same as the top with a different greeting at the bottom. So go ahead and get that copied, enter whatever greeting you would like, and we'll move on to the Makefile. All right, so here's the Makefile, and we will start by looking into what a macro is. So a macro is a piece of code or like a variable that can be reused without the Makefile or throughout the Makefile, and so it just replaces whatever you have on this side with wherever we have it over here. Now, if you would like uh, more in depth onto what a Makefile is, and you would like all the rules, there's a couple of ways to look that up. So we'll look into here, and this is one of the built-in rules. There's also index, so if you just go make manual there, and then we have different ways to actually have. You can download it as a zip file. Um, there's multiple, or view it as a PDF, or printed copies even. So um, that's a good site. So back to it. What this is saying here, these are our macros, and we're going to use those within the code here. So first of all, we're going to define a target action. So this can actually be called from the outside. It's called make all. So that's going to build everything defined within this function here. Now, what you have here is this is the target, or in this case, it is an action. It is a well-known action by the Makefile. So everybody always knows, when you don't supply anything, it looks for the all action and it runs that when you call it from the command line. So it's nice to go ahead and define what it is. So right here, this is print greeting 1, and we're going to define print greeting 2. Now what that says is this is the target, and then you always have dependencies. All right, target and dependencies. Well, it just so happens in this case, these dependencies are targets themselves. So what we're going to do here is we're going to define what print greeting is. So print greeting 1, what is print greeting 1? Print greeting 1 is going to be its own action. So then we define what the dependencies are for print greeting 1. And to build print greeting 1, this is going to be building our executable here. This is what we're going to define. So print greeting 1 is going to be our executable name. And then what do we need in order to build that executable file? It is print greeting 1.0. So we need the object file. If you're not familiar with an object file is, when you have a AC file, it needs to be converted into an object file before it can be converted into an executable file. And by doing so, the compiler, it runs through the optimizations and stuff like that, and it prepares it to be linked up if it runs through the linker before execute, and so Some of the code's readable, but most of it's already in machine language. And then by the time it gets to, the executable, it's definitely in assembly code. So this is print greeting one.o. So that's one of the dependencies. And then the second dependency here will be we need the shared library. So we can type in a new macro, shared libs equals shared lib greetings.o. All right, so that's shared libs greeting.o. And that is going to be, we need to make sure that we have the object file of our shared libs greetings. So to use a macro, and you do the money sign, open parentheses, type in the macro name, and then close parentheses. And that will, in turn, when we run it, just place this code where that is. All right, super easy. All right, so now that we have defined, the entry point for this action, uh, we're going to go ahead and tab. So tab's very important. That means we're about to run a command on on the shell, on the compiler shell. So what we need here is our CC. And what CC is, it just translates into the lowercase cc. And as you can see, what that means here would be CC. Well, right, if you ran it with no files, then it's saying, what is that? Now, if you want to learn what that command is, you can always type man cc. So that opens the manual for the command cc, and that'll drop you into the manual file. And that tells you GCC, it's a GNU compiler and C++ compiler. And there is just a ton of information here. So you can get lost for days. And what we're looking for is the specific option that we're going to supply with the cc command, which is -c. And what that says is compile or assemble the source code, but do not link. So the linking stage is simply skipped. The ultimate output is in the form of an object file for each source file. Easy enough. Okay, so basically what that is saying is when the compiler receives this CC flag, which we're about to supply, so we go there, and then, um, well, I'm sorry, we are actually leaving that out right now. We are not using the CC flag here. What we're using is we're using the -o flag. And what the -o flag does is that just saying, what is your output file? Well, being that we are leaving out this command, the compiler knows we're actually creating a executable file. So the output of what do you want to name this executable file? And right here we could type in print greeting one, no problem. Or you can use the built-in variables, which kind of change depending on what we're doing. So there are what they call implicit rules, and this is an action we're specifying. Uh, so for right now, this symbol is going to be whatever that is. So we don't have to reprint it. And if we ever change this, if we were to change it to that, the output executable file would also change to whatever we just typed. But for right now, we're going to leave it print greeting one. So that is actually just referencing that. No problem. And then we're going to reference that one more time. However, we're going to change how it looks. We're going to append a lowercase 0 to the end. And then, just to be slightly more confusing, we're going to use the shared libraries. All right, so what this says is when you go to compile uh, a new executable, you need the compiler name, and then immediately followed, or not the compiler name. You need the file name after the O, because that's what do you want the output as. But then you have to show the dependencies that are required in order to build your executable. And it's basically just the same as you see up here. So we could copy paste this in place of this. However, I'm showing you how to use the built-in variables, dynamic variables, I guess you could say. All right, so that's going to build print greeting one, and then we have print greeting two, which is exactly the same as this. So let's just copy and paste. So that is print greeting two, colon, and then put the two there. And then that's all we have to change. So because everything else is using variables. And that also speeds stuff up. So as you add more and more, you only have to change the name in one line. Everything else falls into place. So this says target that, print that, target this, go down there. All right. Then what we need is the clean action. So let's go ahead and find that. So when we run the command clean, what it'll do, it'll go through and it will remove all of the files that were built during the Makefile. And so now that we have all that established, if we were to run this as is, let's go ahead and test that. So if you have everything here, you can pause it right here if you haven't finished typing everything. All right, so we're going to go ahead and try and see if this works. So there are what is in there, and then we're just going to type in make space enter. All right, so what has happened here? We have went through and the first call is C and then C and then nothing and then C and then O. So we have double parameters here. Double parameters. Why do we have double parameters? Oh, I know why we have double parameters. Because we defined what C flag is. And let me show you what that really means. All right, so we have these implicit rules here. Okay, and implicit rules mean these rules exist in the background. So the catalog of rules, and let's see if we have one that we can use. Suffixes, okay. All right, well, we're just going to write one. So we're going to overwrite what they already have. All right, just for learning purposes here. If we removed the C flag we have assigned, then this would have ran accordingly. But what we're going to do is this is an implicit rule that exists behind the scenes. All right, and how it looks, so do that, and then CC, they're actually using these macros. We defined them here, but they are actually used behind the scenes, and it's only these two. It's CC and flag, so it depends on whatever you set those to. These rules in the background are automatically done. And what they do here is for this specific rule, what that is saying, the compiler, it's built specifically for the compiler. It's saying take any C type file and output an object type file. So when it gets to this point, and it's like one of the dependencies is greetings 1.0. Well, we don't have one yet. Well, do we have a print greetings.1? Yes. Well, is it a C type file? Yes. Well, then run this. And it runs this and it outputs the dependency you need. However, in the background, they already add that in because they don't want to link it. They just want the object file. As we've seen, that's what it does. So this command. However, we added it again because within their code, they have C flags. already there. So you could add additional commands if you wanted to this command. However, we don't need that to happen. But so, and then I believe they use the money sign and the less than, which is the target name of the C file. And then they would do the output, and then they would do the money sign with the at signal. And that would be the automatic name. So basically they're taking, this is how this would look if you had the actual code. So when it found a C file, it would output, it would go -O, whoops, and it would append a 0. So that's saying that's exactly what it's looking for. It's looking for a C file, and then that's what it uses. So it randomly searches, not randomly, but it goes through recursively in that directory, uh, stays in the same directory. It doesn't go into other subdirectories, and it builds, it outputs the object file. So that is, I would say, one of the most confusing parts about the Makefile so far I've run into, because that command right here is automatically changed to this file type. However, down here, this command is of type this with no .c at the end, and we have to manually add the .o. So there is a difference depending on, are you overwriting implicit rules? Are you overwriting pattern rules? Or are you generating a type of, I believe they call these actions. There's probably another name for them. So just be on the lookout for that. All right, so we manually define this. We're going to remove that, and we're going to override it. So let's see if this works now. So when we go back into here, we type in make clean. So it removed everything. We're back at the start. We type make space enter. Hey, there we go. That's much cleaner. Okay, so what that has done, it says, hey, CC compiler, what's the option? The option is C. All right, what's the first thing we need to do? Well, we need to run print greetings. All right, print greetings. We need the object file. So what's it do? It gives us an object file. What's the second thing we need to finish print greeting 1? We need the shared libs file. Well, it goes and finds it, and it gives us the object file. Now we can finally run the code below. Now that we have all the prerequisites up here that were defined, prerequisites exist. So we are running with the no C flag, just the output, and that is your executable file there, which uses both dependencies it just created. Now it goes down to the second action, which is print greeting 2.o. So it's here. Again, it says it's missing the object file. It goes ahead and produces it. And then the shared libs greeting has already been produced up there. So it skips it and it just goes straight into it. Says all the dependencies exist. So that's what it does. And then we should have 2 executables. And you can tell by here. That X right there stands for executable. So print greetings 1 is executable and print greeting 2 is executable. And to run an executable, you do period, /, and then print greeting, and we're going to do 1. And there we go. And then print greeting 2. And that's that. So great, everything worked. And hopefully you have a better understanding of how these implicit rules can be overwritten and or understood, especially, like right at first we were like, oh, well, we have 2 flags going into here. So obviously it was already tagged into there. If we had just left it the way it was and we actually just removed that whole piece of code and we removed I think that was the only spot we're actually using it, right? All right, and we remove the whole declaration there, and then we go back in, and we're like clean. All right, we clean everything, and then we make everything again. everything should run just as expected. So if you were matching up this with that, um, it just seems cleaner. Okay, so it's making us define the output. Hmm. Well, I wonder if it would still everything work great. It seems a lot cleaner. Okay, so it still does run fine, but it does seem a lot cleaner when you know exactly what is going on. So, you know, it has placed the O. So whereas up here we do see the name output as, and then down here it's different. They do both commands and then output, and it's still. Oh, I see. Okay, so it did the output file here, and then it said the dependency, not that the object file, and then what's the dependency of the object file is C. So we just kind of moved it around to where it's easier to read when we read it like this. All right, so hopefully that made sense. There is a Makefile tutorial 102 that you can watch, and in that one, we are taking a Makefile and building, we're running commands within other Makefiles. So it is a subdirectory. So we'll have a parent directory, and then there'll be two subdirectories, and then one of the subdirectories will be a project to build an archive file, which will be referenced by the other project, which is the actual program, which references the archive file. Now, an archive file will be more than one object file uh, placed together into an archive file, and the project will contain a total of 3 makefiles. So the top level makefile will then call upon the two lower subdomain or directory makefiles, and you get a larger project built all under the command of just make all. And there we have it. So hope you enjoyed, and hopefully I'll see you there.